you who have visited the Pari Center, he needs no introduction, but for all of our new friends here, here's a little bit of a background on Shantena. So he worked as a theoretical physicist at the University of Milan and California. And in California, contributed to the first identification of the black hole. In the 1990s, he was a scientific consultant for the Eleanor Foundation in Switzerland. He has studied Chinese classics and produced various translations into Italian and English, including the I Ching, Tao Chi Ching, and Lao-Tzu. Welcome, Shantena.
Wonderful. Okay, Tao and the Implicate Order is the title of this talk. It comes from two books that I've been closely involved with. One is David Bohm's Wholeness and the Implicate Order. In the early 90s, I had the good fortune to be asked to translate that book into Italian, which was a quite in-depth exploration especially of the philosophy behind the idea of wholeness, the idea of implicate order, and what David called the hollow movement. About 10 years later, I started translating and commenting the Tao Te Ching. That's an ancient Chinese book whose origin is probably around the 4th, 5th, 6th century BC. Extremely compact and poetic. And it had been for a long time my favorite book. Like, what people say, like, if you were stranded on a desert island and you can only have one book, what would you choose? I would choose the Tao Te Ching. For many years, I've been like collecting all possible translations I could get hold of. But finally, I decided to collect all that in a book, to give my own reading and translation of the text, but also include all my favorite translations by other people. So those two books, like Bohm, Wholeness and Implicate Order, and the Tao Te Ching, seem to be far away from each other, certainly in time and space, and maybe also in language, in style. But I feel there's like a common current of wisdom running through them. The same type of wisdom as I hope to be able to argument in this talk. They are also, in a sense, like two sides of myself, because one side is the physicist and the other side is the seeker, the wanderer. I will start by reviewing Bohm's notion of implicate order, especially in the perspective that Basil yesterday called like overarching philosophy. So we will not go into any mathematics and any concrete physical representation, but we'll look at the and how that resonates in some strange way with this ancient Chinese text from 2,500 years ago. So, but it's probably good to start looking at the implicate order in terms of what's the physical origin of that idea, of that approach. And the physical origin is in a phenomenon, a quantum phenomenon called entanglement. So we'll explore a little bit the origin of this notion of implicate order in connection with entanglement. I would like to share my screen now. Shall I just click on share screen?
Just a moment, Shantena.
We can do it.
Do you want to do it, or do you want us to do it?
Oh, it's fine if you do it.
You want us to do it? We were
Yes.
ready to do it. I thought that's what you wanted us to do. Okay, we'll do it. We're going to share, okay?
Okay, so I open the image that I would like to
Yeah, you
see.
can.
It's going to appear in a couple of seconds.
Okay,
There it is.
okay, thank you. Now I see all kinds of things which have nothing to do with my screen.
It's just a point.
What the Chinese would call the 10,000 things. They just suddenly appeared.
It's still coming. We're just
Yeah. It's on its way.
on its way.
Boom. Now you see that.
Yeah, and then if you
Okay, that's the image. Voila, magnifico. So, entanglement, the classic experiment showing entanglement is the so-called EPR experiment, Einstein-Podolsky-Rosen, which was proposed by Einstein in 1935. And in the context of Einstein conversations with Niels Bohr. So let's have a look a little bit at the background of those conversations. Let's move one slide forward. Can I do it here? Yes, I can. No, but that's not the one anymore.
Is that the slide, Shantena?
No, let's move two backwards. No.
So this is the first slide. And then the second one is this one.
This is forward. There's no. Oh, maybe I think you have a different.
Okay.
Can I share
Yes.
Yeah, you share your screen.
on my computer?
So then we do shop share, and I am going to make you co-host,
Okay.
Shantena, which is necessary.
Okay.
Voila, you are co-host, and now you can do share screen.
Okay. Now.
Yes.
Do you see Niels Bohr and Albert Einstein?
So if you click on play, then we will see the
Then you
whole.
will see. Free keynote updated. Huh?
There we are.
Are you with Einstein and Niels Bohr?
Yes,
Okay, great.
I am.
So, quantum physics was difficult to digest, even for some of the people who created it. And one person who was like struggling with it for a long time is Albert Einstein, to whom we owe a fundamental step in creating quantum physics. But he was not happy with the way the philosophy of it goes. He was not happy with the Copenhagen interpretation, particularly. He was not happy with the idea that things don't have intrinsic properties, what we could call the non-realistic character of quantum physics. Einstein was convinced that that was the fault of incompleteness of our understanding of it. He was convinced that there are some hidden variables that quantum physics does not touch upon. And if we could be aware of the hidden variable, a clear order in the nature of the physical representation of reality, like the one of classical physics, could come back. So we had many long discussions with Niels Bohr, in which Einstein's strategy consisted in proposing imaginary experiments. Physicists do that a lot. Imaginary experiments are sometimes as instructive as real ones. So you would propose an imaginary experiment which meant to show that quantum physics was insufficient or contradictory in explaining it. And Niels Bohr was very clever in answering these objections and would usually be able to show Einstein that yes, quantum physics could embrace that particular phenomenon. But the masterpiece of these challenges that Einstein proposed is the 1935 EPR Gedanken experiment, thought experiment, that he published with two colleagues, Podolsky and Rosen. So it's universally known as Einstein-Podolsky-Rosen or EPR experiment. Now I want to go one page forward.
So Shantena, if you click on the slide, it will...
Can you instruct me on how to go one page? Okay.
Yes.
Okay, yeah, here we are. So what does the experiment consist of? There's two particles which are tied together, and they have a property called spin. Spin is the quantum analog of rotation in classical. And unlike rotation in classical physics, spin is quantized, as quantum properties are usually want to do. So we'll consider only two values of spin. Consider particles whose spin can only be, let's say, up or down, and we represent it with an arrow pointing up or pointing down. So suppose that we have two particles whose spin is anti-correlated. For example, because they've been bound together as a zero spin system, so each one has, they have opposite spin of each other. Now, these two particles separate, fly in opposite direction, and are detected by two observers called in this picture Alice and Bob. This, by the way, is not the original Einstein, the original form of the Einstein experiment, but it's a very clear, it's equivalent to it in a very clear form, and it's due to David Bohm. So the two observer, Alice and Bob, are each one endowed with their own spin analyzer. And what is a spin analyzer? A spin analyzer is simply a magnet, and when a particle with spin passes through the magnet, its trajectory gets deflected in a way which depends on the spin of the particle. So let's say if the particle is spin up, it will be deflected, for example, up. If it's spin down, it will be deflected down. So Alice and Bob look upon the particle arriving on a screen and can read what was the spin of that particle. What was the spin of the particle in that? For example, in the image here, Alice is measuring spin along the axis A, and Bob is measuring spin along the axis B. Now, the question we are asking, the question Einstein was asking with the experiment is, are there correlations between what Alice sees in various directions and what Bob sees in various directions? Well, quantum physics predicts not only that there are correlations, but there is a very special kind of correlation. Because the other thing that we need to know about spin to understand the experiment is that the measurement of spin in various directions is not necessarily compatible. Like for a moving particle, position and momentum cannot be measured at the same time. So spin in different directions cannot be measured at the same time. And spin in perpendicular directions is completely incompatible. They're complementary observable, meaning that if you observe a certain value of the spin along a certain axis, you lose all information about the value of the spin along another axis. Okay, here we go. Alice and Bob measure their particles, and there is a correlation. And the correlation, let's say we could take like all the instances of the experiment in which Alice measures it with her magnets vertical up, like in the picture, along the axis A. And let's say she gets the result up, her arrow is pointing up. Then since the two spins are anti-correlated, if Bob is measuring it in the same vertical direction, then he will necessarily get the result down, the exact opposite of that. But if he measures it in a perpendicular direction, there will be like no correlation between Alice. He could get up and down indifferently. Making a number of repeating the experiment a number of times with Alice magnet vertical and Bob's, let's say, horizontal, would give random up and down for Bob. And of course, the opposite is also true. So if Bob holds this measurement, let's say, vertical up, Alice will see very different results depending on she measures vertical or she measures horizontal. So that's something quite peculiar here. One thing which is peculiar is that Alice and Bob can be any distance from each other, and the experiment can be arranged in such a way that they cannot exchange any signal, any information with each other, but still the statistics of the results that Bob measured depends on what Alice has chosen to measure. So the position of Alice's magnet influences the statistics of Bob's result, and vice versa. The position of Bob's, it's as if the particle that's flying towards Bob knows about the experimental arrangement of Alice, and vice versa. Independently of any distance between the two observations, And we could imagine that the magnets are rotated so rapidly that not even a light ray can transmit information to Bob about what Alice's experimental setting is, and vice versa. So this, which is, it's a correlation, and it's not carried by any concrete signal. It's what Einstein called it like a spooky action at a distance. It comes quite contrary to classical physics. It's quite contrary to that things here can influence things there only if there's some concrete signal going from one to the other. Entanglement is somehow conveying information independent of any signal. This is sometimes mistakenly interpreted as a violation of relativity, which is not the case, because in fact there is no one-to-one correlation between Alice and Bob's results. There's a correlation between Alice's results and the statistics of Bob, or Bob's results and the statistics of Alice. So nothing can be said about a single pair of particles, but there's a clear correlation when we repeat the experiment a number of times. This property, entanglement, is nowadays considered a well-verified and standardly accepted notion. It's even used in the work to build a quantum computer, because although entanglement cannot transmit instantaneously information between Alice and Bob, the instantaneous correlation that is there when it's associated with a classical signal can transmit information faster than in a purely classical way. So there's all this work, there's many people interested in the notion of a quantum computer, and that's based on the notion of entanglement. In 1935, this was such an unusual idea, non-intuitive idea, that Einstein could use it as a challenge to quantum physics. If quantum physics predicts something so weird, so spooky, it cannot be right. And Niels Bohr was actually quite taken aback by it, and was not as convincing in his answer as he had been in other of Einstein's challenges. So this 1935, this remains kind of a puzzle for a number of years. And the next step in the story is 1964, John Bell derives a very elegant little theorem about the EPR experiment, disregarding the physics of it and taking into account simply the logic of it in terms of two properties that he calls realism and locality. As that's what we've been mentioning, realism is the idea that the properties of a physical system are somehow in the system itself. not just in the eye of the beholder. They may be partly in the eye of the beholder. When I see a red object, all kinds of processes are going on in my nervous system, which are not describable as red, but there is the fact that the object absorbs certain frequency of radiation and reflects other frequency of radiation. That's an intrinsic property of the object. Locality, as I said, is the notion that things signal by transmitting a signal. So John Bell was able to show that a local realistic description of the EPR experiment and the quantum description do not match for some specific angles. It's either or. Either quantum physics is correct about it, entanglement, or locality and realism are applied. So, well, the experiment was finally done, late 70s, early 80s, and came unequivocally out in favor of quantum physics and not of realism and locality. So, since 1980, we know that the universe is not simultaneously realistic and local. Could be one or the other, but it cannot be both at once. And if we take realism and locality as a description of our ordinary notion of a thing, an object, then I would say since 40 years ago, we know that the world is not made of things. What appears to us as things are objects is not quite. So Bohm's interpretation of EPR Bohm's interpretation chooses one side of the dilemma of realism and locality. By restoring realism, restoring the idea that particles have positions, they have trajectory, and we've seen them. We've seen that what Chris Stutney showed us, and giving up the locality completely. Introducing the notion of quantum potential containing simultaneously about the whole universe at the same time. So in this interpretation, the correlations between the observations of Bob and Alice are because the quantum potential informs Bob of the setup of Alice magnet and vice versa. The quantum potential transmits information instantly at any distance. And here we come to the more like overarching philosophy aspect. Eventually, the interpretation of entanglement, Bohm reached like a deeper understanding of the notion of entanglement in terms of implicate and explicate order. So the particles on the explicate order are two separate objects or we can imagine them as two separate objects that fly in different directions, are observed by Alice and Bob. But that's only a surface and apparent, which was Bohm called explicate structure of experience. Behind it, there's an implicate structure, which is not evident, it's not apparent. But the two particles, the two arrows pointing in different directions, they're rooted in this deeper reality. So the correlation between the results of Alice and Bob are because this is explicate phenomenon rooted in a deeper reality, in an implicate order, which knows no separation between the observation of Alice and Bob. So Bohm introduces this notion of implicate order and gives some nice representations for it. Let me. The first, this Bohm in Wholeness and Implicate Order use various analogies, metaphors for the implicate order. And one metaphor is the hologram. What's a hologram? Hologram is like, it's a laser light which passes through a half-silver mirror, which splits the beam in two beams that we call one of them the object beam and the other the reference beam. They are superposed in the original laser. So they're, like, say, a photon traveling along those paths, like in quantum physics, these strange things happen. So these two beams are coherent with each other. One of them illuminates an object, shown here on the right side, like a bucket or a cup on the right side of the picture, and continues on. And the other one, the reference beam, is simply directed to a photographic plate, which here is represented by this green picture of a cup there. So these two beams recombine on the photographic plate, interference pattern, and the interference pattern contains information about the whole path. So all information about all the possible trajectories of the path through the object. So when we send laser light of the same frequency as that we've used to create the hologram, when we send it through, looking at the photographic plate, we see the object in 3 dimensions. That's the property of a hologram. And another interesting property of a hologram is that the information about all parts of the object are contained in each point of the hologram. If we illuminate only part of the photographic plate, we don't see just part of the cup. We still see the whole cup with less detail. Also, in 3 dimensions, we can look at it from different perspectives. If we only reduce the part that's illuminated of the photographic plate, we cannot see it from so many different perspectives. But the metaphor, what the metaphor conveys is that the interference pattern on the photographic plate contains, each point of it contains information about the whole object that's holographic. So it's like the interference pattern on the photographic plate is like the implicate order, which gets explicated when illuminated with laser light into the 3D appearance of the object. That's one metaphor for implicate order. Let's go to the next picture. Yes. Another analogy that Bohm uses in Wholeness and the Implicate Order is a fish tank with 2 cameras pointing on it at right angles. I couldn't find an image of a fish tank with 2 cameras. Sorry. I've had to contain myself to just 2 fish. But let me just describe the experiment as Bohm proposes. I have 2 TV cameras pointed to the fish tank at right angle, and so when I look at the movement in one camera and the other, let's suppose that the 2 screens connected to the 2 cameras are in a different room. So I'm just looking at the images picked up by the 2 cameras, looking at the fish from at right angles, from 90 degrees. Now I look at the screen and I see that obviously there is a correlation between how one fish image moves on one screen and how another fish image, or perhaps the same, this I don't know, is moving on the other screen. There's a definitely correlation, synchronicity. The dance of the fish on the 2 screens has a resonance. If I were to look at this in a naive way and didn't know about the existence of the fish tank and the TV cameras and so on, I could construct a theory in which the movement of a fish on one screen acts on the fishes which are on the other screen and makes them move in a certain way. That's the style of interpretation that we use in classical physics and to some extent in quantum physics to describe the interaction between people. They exchange messages, they act on each other, causing some change. But when we know about the fish tank and the cameras and understand the whole apparatus, we realize that there is no direct interaction between the images of the fish on one screen and the other. They're related through something deeper, which is the fish tank and the camera. That's the common reality behind them, behind the appearance emergence of separate particles and interaction. So Bohm suggests that non-local quantum correlation can be understood in the same way, can be understood in terms of another level of reality. They are, so to speak, projections of a higher dimensional reality into a lower dimensional reality. If we know the higher dimensional reality, the implicate order, it contains all the explicate order. The third example, the third experiment that Bohm describes in Wholeness and the Implicate Order, let me go on one page, is the apparatus that Basil has described us yesterday. Let me remind you of it. We have two coaxial glass cylinders, and in between the two, there's a very viscous fluid, for example, glycerin. Now, we can turn, for example, the inner cylinder, or you can turn one cylinder with respect to the other very slowly, and a very dense fluid, when it moves very slowly, each part travels along a very definite. It doesn't get mixed. There's no mixing, there's just transport, no diffusion. Now, imagine that you put a drop of ink in the glycerin at a certain point, and then you turn the cylinder. The glycerin moves, and the outer part, and the outer and the inner part will move with different velocity, so that the drop of ink will start spreading and becoming gradually a line, a thin line. But at least in an ideal dense fluid, if we rotate the cylinder back, the particles that compose this thin line will recombine in the drop. So in some ways, it's like when the drop of ink is spread out in the glycerin, it's kind of infolded there. And when we rotate it backwards, it unfolds. It was implicate in the pattern in the glycerin, and then when we turn it backwards, it unfolds in the explicate droplet. Now, Bohm elaborates this quite a bit further. You can imagine, for example, that you have two drops of red and blue ink next to each other. Then you rotate the cylinder, they become thin filaments, and these filaments may cross, not cross really, but it can come close to each other, and can fill up the whole space between the cylinders, so that the red and the blue gets apparently mixed, becomes invisible what's separate red and blue. But wait, if you turn the cylinder backwards, now all the red particles of ink find each other and recompose the red drop. All the blue ones recompose the blue drop, So what appeared to be like a completely mixed situation contains within it an order which recomposes itself when you turn the cylinders backwards. Bohm says it's as if red particles knew that their destiny is to join with the other red particle and recompose the red dot. And the blue particles knew that their destiny is to recompose the blue dot. And a further step of this analogy is you can imagine this experiment. Put in a drop, let's say drop A at a certain spot, then turn the cylinder a number of times, n times, let's say. Then you put another drop B very close to drop A, turn the cylinder a number of times, put a drop C very near the place where you originally had put A and B, and so on and so on. What happens when you turn the cylinder backwards? These drops will reappear in the opposite order in which you set them in. So the Z, W, Y, C, B, A drops will reappear. If we imagine that this is happening with sufficient speed that we cannot distinguish the individual particles, the individual droplets, this will appear as a continuum motion in space. So Bohm proposes that this is quite a different way of conceiving motion through space. It's not like a concrete object moving through concrete space. There's a deeper reality. There's an underlying implicate order out of which the appearance of a particle moving through space is manifested. Let me read you Bohm's comment on this. I've had to retranslate this from my translation into Italian, so it might not be completely exact word by word, but he says, this folding and unfolding of the implicate order can provide us with a new model of a particle, for example, an electron, quite different from the present mechanical model. The essential aspect of this new model is that it understands the electron as a whole sequence of enfolded ensembles, which are not in general spatially localized. In a more fundamental sense, the particle is only an abstraction perceived by our senses. So in the EPR experiment, there's what appears to us as two particles having this spooky action at a distance between them can be read as their like local explicate manifestation of an implicate order, an order movement, which is a deeper level of reality. Now, I want to read you a couple of quotes more by David Bohm, which I will use later about Tao.
Eleanor, Shantena, I think your papers are on your mic.
Okay. Thank you. Okay. Can you hear me well?
Yes, this is better.
Right. let's go on one picture. One more. Yeah, remember the beginning of Howard's documentary, the conversation between David Schramm and David Bohm, in which Bohm says, look at the sky and look at empty space as if it's full. In Wholeness and Implicate Order, Bohm writes, empty space, the plenum, is the ground in which all existing forms are rooted. Things as they appear to our senses are derived forms, and their true nature can be grasped only when we consider the plenum, by which they are generated and supported, and in which they must finally dissolve. Now, lovely quote in which if you replace plenum with Tao, it could be literally Laozi speaking, as we will explore in a little bit. Notice also this, all the things that are here generated and supported and in which they must finally dissolve. In Chinese thought, the Tao is what generates and supports the 10,000 things. And Lao Tzu says, return is the movement of the Tao. Explicate and implicate. Let me look at another quote here. David Bohm says, inanimate matter is a secondary abstraction derived from the hollow movement, just as it would be the notion of a vital force independent from matter. Truly, the hollow movement, in which life is implicated, is the foundation of both explicated life and inanimate matter. And this foundation is the primary reality, autonomously existing and universal. Therefore, let us not separate life from inanimate matter, nor try to reduce the former to a consequence of the latter. Again, that he replaces all the movement with Tao, and apart minor language differences, it could be Laozi speaking. Notice that in Chinese, peculiarly, the word Wu means being and object at the same time. There is no sharp distinction between animate and inanimate. So one Mu is at the same time the 10,000 beings, the myriad beings, or the 10,000 things. Okay. I let David Bohm rest and move on to the Tao. So let me go on to the next slide. Thank you. So Tao is what we call Daoism, is both a philosophy and a religion, but we'll be interested particularly in the philosophy aspect of it, and it's characterized by a skeptical relativistic attitude to knowledge and language. In that way, it's quite similar to postmodern thinking, and has an emphasis on direct experience, spontaneity, simplicity, and non-doing, which does not mean inertia. It's not literally non-doing, but it's a special kind of doing, which is like devoid of ego involvement. It's kind of like helping nature run its course. David Peat used to like this expression that humans are midwives to nature. Non-doing is a form of midwifery to nature. Let's go on one image. The Tao Te Ching. The Tao Te Ching, many of you certainly know. It's a small book. It's 81 chapters. It's 5,000 characters altogether. And it's traditionally attributed to Laozi. I'm using the pinyin romanization of Chinese, which is now slowly becoming the official one. But we're mostly more familiar with the old Wade Giles romanization, in which Lao Tzu was Lao Tzu, the Tao Te Ching was the Tao Te Ching. Okay. Traditionally attributed to Lao Tzu, but modern scholarship is quite skeptical about that. And the information we have about Lao Tzu comes mostly from stories of meetings with Lao Tzu, which would put confusion, would put Lao Tzu in the 6th century BC. But as I said, modern scholarship tends to consider it as more recent, probably 4th century BC. And it's unclear, to what extent the book is a compilation of various authors, and to which extent there's a historical Lao Tzu author of the book. But all lovers of the book love Lao Tzu, whether he was real or not. And one sinologist, Richard Wilhelm, commented that Lao Tzu would have enjoyed being considered legendary. And all his life, he is trying to erase his footsteps, his traces. There's a nice legend about the origin of the book, and we can go to the next slide. The story goes that when Lao Tzu was old and the Zhao dynasty was in decline, he decided to go and die in solitude, retire in the Western land. West of China was like the wild Central Asia land inhabited by barbarians, where the Chinese was out of the world. When you reach the boundary of the kingdom, the boundary of the Chao empire, a soldier, a guard, stops him, recognizes him, and says, "Master, if you retire and you go away, you should write us a book." And the story goes that Lao Tzu never wanted to write anything, and in fact, the book, the Tao Te Ching, begins with the famous sentence, "The Tao that can be spoken about is not the Tao." So, what can one write about the unspeakable? But somehow he gets touched by the sincerity of this lonely soldier on top of the mountain. So he dismounts, he sits down, he stays for some time with the guardian of the past, and he writes the Tao Te Ching. So that's the origin of the book, is this kind of peculiar happening. Without that guardian of the past, we would not have the Tao Te Ching. This story is told in a very nice, humorous way. In a poem by Bertolt Brecht, which wants to show like the student is as important as the teacher in the miracle of transmission. Okay, let's go on to the next slide. Yeah, so let's have a look at this notion of the Tao, which the book starts by saying it's not speakable. It's the unspeakable. It cannot be conveyed into words. The word Tao essentially originally means way or road or path. That's the root meaning of the word. And in fact, in China, it's still used also as street. But then, as it often happens with Chinese characters, that they move into, by kind of free association, into a number of other meanings. So this way also becomes a way in a moral or philosophical sense, a guiding principle. So it means also to lead, to direct, to govern, doctrine, art, method, power, and so on. Discourse, teach, speak. That first verse of the Tao Te Ching in Chinese sounds Dao Ke Dao, Fei Chang Dao, where Dao Ke Dao, that second word, which we translate as Dao that can be spoken. In Chinese, it's again Dao. So that a literal translation of the Chinese would be Dao, possible Dao, not constant Dao. But anyway, this notion of Tao, road, path, guiding principle, doctrine, and so on, was already widespread in China before the Taoists, and was a standard philosophical term. In philosophical debates could be viewed as debating what's the guiding principle, what's the right way, what's the correct discourse, what the true teaching, and so on. And especially the Confucians, the disciples of Confucius, and the Mohists, the disciples of Mozi, would confront each other and fiercely debate about what's the right way. The Confucians were like conservatives. For them, it was like going back to the pure tradition of the ancient. And the Mohists were like more reformers. And they were more like into technical, natural, rather than tradition, words, the ancient text, and so on. Now, the Taoists step into this discussion about the true Tao in a radical way by asking, is there a true Tao? Is there a true way? Is there a universal guiding principle? And they claim can no. The Confucians say, let's go back to the ethical principle of the ancient. The Taoists view like they are quite suspicious of all ethical prescription. They see it as a late remedy for having lost the spontaneity of the human being. That spontaneity which is in touch with the true, with a deeper level, with an implicate order, and not prisoner of the images of what appears. So let's move on one. So the first reading of this first line of the Tao Te Ching, Dao Ke Dao Fei Chang Dao, is simply this skeptical argument of the Taoists. There is no constant way. The way will be different depending on which angle we look at it and which interests guide our reading of it. Let's go on one slide. Yeah, this is the second one. We'll go back to this one. Let's move on one more. Yeah, this Taoist skepticism about language, doctrines, systems reminds us of the attitude of postmodern thinking, which is like very well represented by Korzybski's famous statement, the map is not the territory. What does it mean? Yeah, like all discourse is a map, all language is a map. The idea that language can capture reality is like thinking that the map can contain the territory. The map is not the territory. A beautiful metaphor for it is Magritte's pipe. Ceci n'est pas une pipe. This is not a pipe. This is the image of a pipe. Magritte called this painting the treachery of images, which is not just images, it's like it refers to all our representations of reality. But the interesting thing is that the Taoist and the modernist meet each other in this initial view of skepticism towards language, but diverge in the consequences that they draw from it. So let's say the modernist, postmodernist consequence is like, okay, if language cannot capture reality, forget about reality. And we just study language as creation of intersubjective reality. The Taoists take the opposite choice. If language cannot capture reality, forget about language. And let's stay with experience. Let's stay with reality. So they take the word Tao and radically reverse it. They radically change the meaning of it. from the meaning of discourse to what is beyond all discourse, what is beyond all representation, what is the ultimate ground of everything, behind all appearances. Let's go on one slide. So, any way that can be told is not the constant way. I've written here way with a capital W. That's the way we do it in the West with Tao. And, to distinguish Tao, the little Tao, which means way, path, road, guiding principle, from this special Tao the Taoists are talking about. The way which is beyond all ways. Okay, let's go on one more slide. The second verse of that first chapter of the Tao Te Ching has to do with names and naming. The verse is completely symmetric with the first one. Dao ka Dao, Fei Cheng Dao, Ming ka Ming, Fei Cheng Ming. Any name that can be named is not a constant name. This naming of Lao Tzu can be read on many different levels. On one level, it's giving names to things, and by so doing, creating the appearance of separation, as if you could talk about an individual object, and also the appearance of separation. Naming is splitting the world into separate beings. For the Chinese, naming is the origin of the 10,000 things. And in fact, the next line talks about that. Let's move on one slide. The next line says, without name is the beginning of heaven and earth. Heaven and earth is the cosmos, everything, the totality for the Chinese. Having name or naming is the mother of the myriad beings or the 10,000 things. This term Wu is being and thing. So naming, separating, dividing the world in objects is the mother of the 10,000 things. Let's move on one more. Now, the first lines of this chapter have kind of created the cosmological frame. Now it talks to us as living beings. And he uses the word desire. The word desire in Lao Tzu covers both attraction and repulsion. Desire is the essential movement of life to preserve itself, to expand, and to move away from what damages it. It's already there at an amoeba level, which moves towards food and moves away from toxic stimuli. It's an essential ingredient we wouldn't be there if throughout evolution we hadn't been moved by desire in this sense. Now, what Laozi says here is that, therefore, when you're without desire, you can contemplate its wonder, the wonder of it, all that we've been talking about before, the wonder of existence. If you are with desire, if you're having desire, you contemplate its boundaries. You contemplate the interaction of separate things. As soon as we are identified as separate beings, we see the world as consisting of separate objects, and we are identified with our own separateness. Then we're stuck with the boundaries. And then we are confronted with what Buddha called in his first noble truth. The teaching of Buddha is summarized by 4 noble truths. And the first noble truth is existence is suffering, which needs to be interpreted, because the word existence is made of ex and sistere, which means standing out. So standing out is suffering. If I conceive of myself as standing out from the rest of the universe, as having a separate existence amongst the other objects of the universe, then I'm bound to suffering. I'm bound to be frustrated because my separate existence is an illusion. It's like a wave in the ocean. If the wave is identified with itself to the point as wanting to persist as a wave, that's impossible. The wave dissolves into other waves. In our modern physics representation, we are like interacting fields that compose this things, this object, this body I am. So the Buddha would say, move beyond, be free of desire, so that you can contemplate the wonder. But that's not exactly Laozi's message. Laozi's message is subtly different, and we see it in the next page. Laozi says, these two is like desire and no desire, name and no name, all that has been talked about before. This polarity, they jointly arise, yet we give them different names. But jointly, we should call them the hidden. This word chuan, hidden, is dark, somber, profound, subtle. It's what's not apparent. So it's below the surface. So kept together, these are this underlying reality. Let me take the challenge and call it implicate order. They are the dark or the profound, and again, the most profound of the profound. The door of all wonders. So that's the message of Laozi. It's not give up the world and move away from it. It's not move beyond desire, abandon desire. It's be in both places at once. Be aware you are the ocean, and at the same time dance your dance as the wave. These two, they jointly arise. We distinguish them. But jointly, they are the hidden. They are the profound. Okay, I think I leave this chapter for now, and I'll give it time. Oh, maybe I will stop here altogether. It's quite late already.
You were very inspired, Shantena, and inspiring. So I know that you actually want to go into breakout, but maybe we skip that, Shantena, if you agree, and we just turn to listening to some questions and reflections from people. Is that okay?
Sure. We could do that, yeah.
Yeah. So can you maybe stop sharing screen?
Okay.
At the top of your...
Let's see, well, I should...
On the top of your window, there should be, in green, stop sharing screen.
Yes, when sharing, stop share. It's in red.
In red. Perfect. Okay.
Thank you. Sorry. I got...
So much, Shantena.
Yeah.
Some clapping going on. Definitely people have appreciated it. But there's some space for questions. So like last time, you can click on participants, which is a button at the bottom, and click the button of raise hands. Or like Eleanor said, we'll scroll around the different screens to see whether you're raising your hand physically. And you can also write it in the chat if you would like to speak. But Peter, you've had your hand up for a while, so why don't you come in first with your question?
There we are. I think I'm unmuted now. Is that right?
Yes, perfect.
Okay. Yeah, the question's a very, very basic question, almost naive, I suppose. But
how can I see you, Peter?
Shantena, maybe you click on speaker view.
Let me see speaker view.
And also spotlight Peter now. Go ahead, Peter.
Yes. Okay.
Yes. It's just a very basic question, a naive question, but I've got an engineering background. So talking about the entanglement experiment, they actually proved this in, I think it was 1980. They actually separated these particles, which I presume are subatomic particles like quarks. Is that right?
No. It's something much more ordinary. It's
like
an atom that gets split.
But what? Well,
let's say electrons. It's
electron. Now then, what interests me is that, as far as I know, you can't isolate an electron. Electron has no rest mass because it's always moving, right?
You're talking about a photon.
Well, whatever these two things are, which are correlated, when one spin up and the other spin down, right? They can't be stopped. They must be whizzing around all the time. So how can you don't put them through the crystal and separate them, and then each put one in a red box and one in a blue box and take them hundreds of miles apart. You know what I mean? How do they actually physically separate these subatomic particles and then measure their spin?
Well, how they measure that spin, it's quite easy, because you have this magnet, and the particle flying through is like a rotating charge.
Yeah, but what I mean is, how do they actually physically separate these two correlated particles by many, many miles, and then do experiments to measure the spin? This is what I mean. How do you presumably they first of all correlate them by somehow send them through a crystal or something like that, and they split, right?
Yeah, they're correlated because they are joined, let's say, in a system of spin zero.
Yes, but how do they physically separate by many?
How they technically split it, I'm sorry, I cannot tell you. I don't know that.
Basil, maybe Basil can come in. Yes, go ahead, Basil.
Yeah. Okay. We actually were the first people at. Oh, sorry, am I on? Yeah.
We can hear you.
Good. Okay. Sorry, I switched off because there were kids outside the window just now.
Hi, Basil.
Hi. Yeah, we did this experiment at Birkbeck College way back in 1968. And we had a guy called David Butt who had been listening into David Bohm and myself talking about this entanglement. And he had some apparatus which fitted what we wanted to do very nicely. Now, what he did and what everybody else has done is correlate the spin of two photons.
Uh-huh.
Now, the way you get the two photons to come apart is that you first form positronium, that is, you have a positron and an electron going around each other like a little atom, and then they annihilate each other.
Yeah.
In that annihilation process, the photons automatically get kicked apart. So you don't have to break them up, they break themselves up. And then what you do is you look at the spin measurements. We were up to 6 meters. We managed to get up to 23 meters, I think, in the end, until we ran out of laboratory space.
But how do you capture them?
No, okay, let me come to that. Now we want to measure the spin direction. And what we do is we scatter it off a crystal.
Yeah.
The way it actually goes depends upon its spin orientation.
Okay.
Okay, so we can actually change the spin orientation as well in our detectors. Yeah. And then we measure correlations. Okay, now that was the experiment we did. We didn't test the Bell inequality, but we just wanted to see if there was any spontaneous localization. That is, if there was any breaking of this entanglement so that the two particles became separate. And we found up to 23 meters. We had the world record at one stage.
Yeah.
The correlation didn't change. Aspect had another experiment, the French guy, Alain Aspect.
Alain Aspect, yeah.
Yeah, he came along later, but he could now design his experiment to test the Bell inequality. But he used exactly the same idea of no, you got it wrong, BJ. What he was doing was photon down conversion. That's an atomic process that occurs off with two photons go off in the other direction with the right correlations. So you don't have to make them go off, they spontaneously go off, and then you measure the correlation. He used a pile of plates, to polarize, to measure the polarization.
Yeah.
And he went 12 meters. But then just recently, Anton Zeilinger has gone out to 143 kilometers.
But how do they physically get from this one laboratory where they're measuring to 143 kilometers away to another laboratory?
I haven't done the experiment. I haven't been to Tenerife. I wish I could go to Tenerife
Yeah.
and have a lovely holiday at the same time and see exactly how they did it.
You need a long vacuum tube.
Yeah.
143 kilometers. No, I tell you one thing, Shantena. It didn't work when there was a storm in the Sahara Desert.
Right, right.
So thank you, Basil, for coming in.
Yeah, thanks a lot.
Very nice. What a privilege! What a privilege we have Basil here.
Right.
Right.
Sorry, Shantena, but I just happened to be in that game.
That's right. Fantastic.
Also a question from Ellen for Shantena. Ellen, you want to bring your question? Ellen Questel?
Yes, hi there. I have to look at my question again. I guess the first part was I heard a resonance between what you were talking about, Shantena, in Daoism and Jung's concept of the challenge of holding the opposites.
Right.
The second part of it I want, and so I'm a psychologist, that from a developmental point of view, I wonder if for those of us in the West, at any rate, it isn't necessary to first move into separation, if you will, to evolve at some point in life in the psyche back into wholeness. I'm not sure if I've stated that clearly.
I agree. I think I don't think that's just in the West, by the way. I think that a certain amount of individuation is necessary if you want to meaningfully talk or approach or walk towards or wholeness.
Good. I noticed I've been studying alchemy for many years, from beginning with Jung's studies of alchemy, and there seems to be the same pattern of individuation, of separation, increasing separation until there is a reunion, if you will.
Right, right. I haven't studied alchemy, but I'm sure there's like many deep analogies there with Daoist thinking, Bohm's thinking.
I think, anyway, thank you.
Thank you, Ellen. And there's Paul Howard. Paul, come in. You're muted, Paul.
Okay, can you hear me now?
Yes.
Yes.
Ah, good. Shantena, how are you? What a lovely presentation. I've often said to you that I think it would have been very nice had Bohm and Laozi got together. I think very compatible friends and partners in their pursuits to unravel the mysteries of creation. When I first got involved with David Bohm, I was very much more attracted to the philosophical aspects of Bohm initially, like the whole notions of emergence, of process, of being, becoming, the stuff in many ways that Basil, and in fact that we were talking about yesterday, the possibilities for transcendence, transformation. And, you know, I love Bohm's idea that consciousness is never static or complete, that everything is an unending process of movement. And I noted that Bohm really states that one never arrives. In other words, there's no final destination. So my question for you, Shantena, is, given that you're an expert in the Tao, is there a final destination in your view? Do we reach a point where we can say that we are enlightened, that we have overcome the world, that we have entered the gate of all wonders, as you so eloquently put it? Or is it the case that this is a journey without end and that we just enjoy the mystery as we go? Do we return to the ground of all creation?
One of the lovely aspects of Daoism is that there isn't notion of enlightenment. So there is no goal. There is no final place to be. There's the wonderful, terrifying game of everything, folding and folding, us blossoming, dying. Yeah.
So in a sense, it's what Bohm refers to as the spirit or energy that is never born nor ever dies. So in other words, it's a continuous process without a destination.
I think Laozi would agree with that perfectly. In fact, in some ways, like Bohm is a contemporary alchemist and Daoist. Yeah, journey.
Okay, so let's enjoy it, huh?
Yeah. Nice being together, Amy.
Lovely question, Paul. We also have Catherine with a reflection in the chat. Catherine, would you like to bring it in the conversation? Katrina, sorry, Katrina.
Okay. No, I was just responding to Ellen's question about holding the opposites, because again, we have this idea that everything's one or the other. Like it's this kind of curse of duality that we can only do this, or we can either experience separation and individuation, or we be part of the collective. And I think, again, I could be sort of bastardizing what Bohm said, but around the Russian experiment, the idea that as we more fully embrace our individual design and then fit into the collective, we actually become freer, which seems so paradoxical in a world where everything seems to be fitting in means monoculture as opposed to fully individuating, which I think is what really, there's a lot that really entertains me here, but the idea that we can actually be fully separate, and the more fully separate we are, the more fully we are in unity, and the more fully we are in the collective, all at the same time. And it's a very different, or it's a very new way of seeing things for me, which really is beautiful. Anyway, so that was my reflection on Ellen's question.
Which is close to the idea of the wave and the ocean.
Mm-hmm. Mm-hmm. Yeah. So thank you for this.
Thank you, Katrina. So I have no other digital hands up, but I'll scroll through the screens to see whether someone has a physical. Yeah, Eddie?
Sorry. So thank you very much, Shantena, for a fascinating presentation. A link I would like to suggest that would tend to concretely link the Tao to David Bohm, where you were saying that the Tao was suggesting that humans can be the midwife of nature. Well, in this sort of new form of dialogue that David Bohm was exploring, but who isn't And there was other people as well as David Bohm, who have, I feel, pioneered the emergence of it. There is the potential that not just that humans can be midwife to nature, but that the humans in the dialogue can potentially be midwives for each other's understanding to emerge. So I would see that, because of David Bohm's passion about dialogue, to be a sort of a link between the two.
Right.
You want to reflect on that?
In a way, the position of the Taoists moving beyond the opposition between Confucianists and Mohists, looking for a deeper ground. It's a form of dialogue. The Taoists maybe were not so interested in dialogue at the level of verbal confrontation, but they were certainly interested in going beyond polarity.
Yeah, and the reason I mentioned the new form of dialogue, because it's quite different than what people might have defined dialogue to be. I live in Ireland, so in the north of Ireland, there was a lot of emphasis on dialogue to bring forth the peace in the end, and that was really valuable. But this is a different approach to dialogue. So the spirit of dialogue in this context, and the spirit of dialogue in the Tao, may be more to do with the spirit of it than so much the structure of it. There may be a resonance, I think.
Okay.
Thank you, Shantena. We have Laili, please.
Thank you.
I still haven't managed to get to the speaker's view. Where is the?
Okay, I spotlighted. Do you see Laili now?
I see it.
Okay.
I see it. Hi, Lee. Hello.
Hi, Shantena. So nice to see you again. And thank you so much. That was really fantastic explanation. It raised a question in my mind. In the Taoist view, what happens to a human being at the time of physical death?
They had a very light and playful attitude to dying. In Chuang-Tzu, there's various stories of close friends who play music together and sing and celebrate in life. And one of them died, and the other one makes some very happy music. And a Confucian, a student of Confucius, comes in and says, "Oh, this is sacrilegious." And they look at each other and say, "The poor guy doesn't understand." They have a sense of, I will die, but the birds will keep singing. The creek will still flow. They have a sense of belonging to the larger cycle, to the larger process.
Is there some part of their spirit that continues, or?
Well, as I said, like Daoism is many things. It's a philosophy, it's a religion, and there are various there's a traditional view in which let's say the spirit of a person at death separates into one which goes up to heaven and one which goes down into earth. There's also a school of Daoism which works towards producing immortality. They believe that there's like a crossing a threshold and moving beyond death. But this is more like the religious aspect of Taoism. I wouldn't be able to find in Laozi or in Chuangzi anything that supports that.
Okay.
Those views.
Thank you for your question. And we have Jean. Jean Robertson, would you like to bring in your question?
Yes, my question is, what is the nature of the guardianship of the past? And presumably, David qualifies.
David Bohm, David Peat, David Schramm.
David Bohm.
All guardians of the past. Yeah, yeah, yeah. That's an interesting. The term that's in, the anecdote is told in an ancient book called The Record of the Historian, and the term that's used for this guardian of the past is quite ambiguous. It's not clear whether it's a spirit, it's a physical person. Bertolt Brecht's song, poem, it's a very simple soul. This soldier is shown as a humble, like barefoot probably, soldier in his isolated outpost, which suddenly meets this extraordinary being and gets charmed by him. But yeah, what's this symbol of the guardian of the past?
So Beth Macy, you want to comment?
Yes. Shantena, I have a question comparing Bohm's work and I take this more from the I Ching than just from the Tao. But it's my understanding in the I Ching that what's referenced is a continuous circle, a continuous evolution, going around the sequence of things. But they always come back again to the start. And in Bohm's ideas, what I understand is that when something re-unfolds into the implicate, that it takes a bit of its experience with it so that there's an opportunity to influence the implicate from what happens at the explicate. So there's a feedback loop in essence. There's a potential for shifting so that it's not deterministic.
Yeah.
So in comparing those two, would you say that the Chinese philosophy you're talking about is deterministic, or do things at the human level have the capacity to impact the flow among those various sequences? Like the circularity. Is it always determined? And is that why there's no end to the journey?
No.
How do they fit together?
I think determinism is actually a quite recent idea. It's dominant in our society, but I wouldn't describe ancient Chinese thinking as deterministic in any way, actually. There was more the idea that by conforming to and interacting with the flow of things, by being in touch with the movement of the Tao, you can influence things, you can shape them one way or another. That's why the question was so important about, like, what's the Tao of this situation, or what's my Tao in this situation? And I think even as the view of nature, it's always had an element of creativity. It was not like coming back to the same point. No winter is the same as the previous winter. No spring is the same as the previous spring. Without necessarily meaning that they evolve towards something. That's not necessarily that idea. There's more the idea of a circularity which renews itself, transforms itself constantly, without ever reaching any final state or goal.
Thank you.
Yeah.
So thank you, Beth, for your question, and Shantena. So there is at this point no more questions, or yes, Chrissy.
Yeah, Shantena, thank you very much for your wonderful presentation. I was always looking to better understand the philosophy behind David Bohm's work and the physics essence. And you helped me to get closer to that. And I have a question. You were speaking about holding the opposite.
Yeah.
In Germany, or in German, we do not have that expression, or I cannot think of it right now. When you say holding the opposite, or when David Bohm speaks about that, does that mean also being in touch, as you said, to the implicate order, to the deeper Tao? And if we do not be in that connection, is it then fragmentation, as David Bohm called it?
That's a good question. Yeah, I think on the level of our personal life and experience, the more we are in touch with the deeper level, the more a kind of wholeness manifests in our life. Ultimately, as the whole universe it keeps creating itself according to its own law. And we are a small part of it, but by being conscious, a very interesting small part. And also have a peculiar responsibility which goes with it.
So
Thank you.
Shantena, we have 2 more questions, but we're running to the end of the time. So there's, and Basil is his hand up. So let's hear from Myra, and then I'll give it to Basil, and then let's see where we are in time.
Shantena, thank you so much. I was struck by your use of the word spontaneity as being connected or connection to implicate order. And it's not a word we use so often in our culture, spontaneity. I was wondering if you could just say a few more words about that. Thank you.
Yeah. Well, spontaneity in the Taoist sense is like it's like in Zen archery. It is said that when you go deep into Zen archery, you no longer are aiming. You no longer are looking at the target and trying to put your arrow there. You just let it happen. You don't stand in the way of the arrow flying straight. There's a nice little story in Chuang Tzu, which uses Confucius as a character. The Taoists like to partly make fun of Confucius or use him as a character in their stories. So he's looking at a waterfall and a turbulent stream and sees a man swimming in it and gets worried that he will drown. But then the man is happily comes out of the stream and is happily singing along the shore. And Confucius asks him, but how is it possible? How do you do it? And he said, oh, it's easy. Like when the whirlpool movement of the water goes down, I go down with it. And when it goes up, I go up with it. That's the Taoist sense of spontaneity. It's like not imposing like rigid programs on reality, but being in tune with the movement of things.
That was a bit like David Bohm crossing the stream.
That's right. Exactly. Yeah, that's a very good example.
So as we're approaching the end of our call, I just want to pass it over to Basil, as you had some closing words maybe for us.
Oh, no, I was just going to pick up.
Reflection, sorry.
Are we live?
Yeah.
Okay, good. No, I was just going to reflect on this idea of holding opposites.
Yeah.
Because one of the things that I experienced when I was talking a lot with David Bohm was that we would use the opposites to cause tension. Because it seemed to me that if you were in your same comfortable mold, there would be no tensions and you'd go to sleep. But if there is an opposite of some kind, you need that to stimulate you to actually consider the two and see if there is something beyond the two. And he would use that quite a lot. So he'd go down what I thought was a ridiculous road, but the reason for it is to generate the tensions between that road and the road perhaps that he wanted to follow. And that's the way he kept the two tensions. And I thought this came from Hegel, actually, but I've never read Hegel because I found him so difficult. I got as far as Schelling and Fichte, but then going further, I just lost.
I also would identify that as Hegel, yeah.
Okay, good. Well, thank you, Shantena.
Thank you, Basil.
By the way, was that drawing?
Having you here?
Yeah. No, can I ask about that drawing that you showed? That's not Jiangsha J, is it? The lovely mountain side beside. I was looking at that rather than the writing. I'm sorry.
Oh, yeah.
Is that from Jiangsha J? It's a really beautiful spot in China, which I had the great joy to actually be taken to when I was in China. And it looked very much like the beautiful kind of scenery that
Chinese landscape.
in Zhangjiajie.
Yeah.
Well, thank you. Thank you both. Shantena, you have any last closing words of wisdom as we...
Let's enjoy the adventure with all its ups and downs.
Okay. Well, thank you. Thank you, everyone, for being here and for contributing. And we're looking forward to see you again next week, Saturday and Sunday. And anything else? I think that's it.
No, thank you everybody for being here. Thank you, Shantena, so much. Thank you. It's a beautiful
so
presentation.
inspiring.
Thank you. Better than church.
Thank all of you. Bye.
Thank you.
Bye.
Feel free to
See you next week. Bye-bye.
Bye-bye.
Bye-bye. Thanks so much.
Thank you, Kristen. Bye.
Bye-bye.
Bye. Bye.